Hello everyone and welcome here on the 12th video tutorial. My name is Paul and today I will talk about seeds and swaps. It's not so important to know every detail about them, but it's good to have some basic knowledge that you are knowing what they are for, how to use them, and you are not confused anymore what to fill in. So you will find it simple, and also you will see the relation of these seeds and swaps to whole generation. At first, the seed is a initial number that determines the unique chain of generated random numbers, and swap is a number that assures you that this unique chain of generated random numbers is still unique, that it will remain unique, and any sequence of this chain will never repeat. So it's important to keep the chain of random numbers unique for the whole generation, as it's running for several days and there are produced billions of random numbers. So that's why we are using seed and swap. Now let me show the seed in the gene. So we have seed 1 and seed 2. If we have lottery just with one draw, like Fantasy 5, we have one draw and we should then fill in only the seed 1. We can fill in like this some whole number, and the seed 2 can remain empty. Then we should fill in also the swap 1, which can be whatever whole number we decide to use. If we have lottery like Powerball with two drawing machines, then we need to also fill in the seed 2, which can be another number, and swap 2 as well. It's important and also recommended that the seed 1 will be different from seed 2, and also the swap 1 will be different from swap 2. Actually, all four numbers should be different one from each other. Other thing what you need to keep in mind, that there can be used only whole number from 1, let's say, to infinity. It can be really big number. You cannot use something like this. There cannot be negative number or number with floating point like this. So this is not allowed. Use this. You cannot use even positive number like that. Yeah, so keep it. We can use here number 1, here we can use number 2. This we can keep. There are same rules for swap, so it should be always positive and only whole number without any decimals or floating point. Other thing is keep empty the seed 1 last and seed 2 last, and also these two keep empty as well, because these cells are used as a storage for the latest seed 1 and 2 and the latest swap 1 and 2, which I will show you later. And this is used to store the generation and its last saved point. And what I wanted to say is it's filled automatically, and it's used as to save the point, and it's used for the transfer function, which I will show later as well. Now I will describe the algorithm of the seed and swap, how it works and how it's programmed directly in the gene software. So we have the initial seed, which we selected or we wrote into the table. It is this one or this one. The algorithm is the same for seed 1 and for the seed 2. So for example, this one is taken as initial seed, creating the unique chain of random numbers, and then it goes to the random number generator, where the random number is function of the seed. The function I will keep secret here, and from this function we will get the new random or first random number, and also a new seed with higher index. The seed goes to the decision process, and in case we will end the generation, then the last seed is saved right here. If we look for seed 1, then it's saved when we end the generation, but usually it's running in a loop, and it's ended only once. So if it's not ended, it goes to the another decision process, where the seed is compared with the initial seed, and if it's the same or not, it means we are checking if the seed is repeated or not, to keep the sequence of chain random numbers unique. So in most cases, and through the millions or billions cycles, the new seeds are different from the initial seeds. So in the most cases, it goes this new seed back, and it's used by the function, and we are getting a new random number with higher index, and everything is running in the loop for billions of cycles. But in case the seed we found, the seed is the same like the initial seed we had in the beginning, we need to swap the seed. So in that moment, the seed is going to the seed random number generator, where the seed is function of the swap number, and here we are using as an initial is the swap number we created in the gene right here. So for the draw number 1, it's taken this number 35, and then it goes to this generator, and it generates a new seed which is swapped and used again in the function, and this will assure us that the sequence of random generated numbers is still unique, and we are getting still new random numbers. In case we end the process like here, is the same condition, then the swap number last one is saved in this place, like here or here, which I will show later. If we continue the process, and here we have a new equality of the seed with this new seed which was swapped, then the process with the swap and seed is repeated. So it goes like here in a circle, we have a new swap from that new seed, and here is again a new unique chain of random numbers we are getting here, and used for the comparison with the real drawn numbers. So that's the basic algorithm of the seed and swap. And now let me show how it works directly in the gene. So we can create some preset, or setting. I will make it very quickly. So we put the count of previous draw 3 and 0 of future draws. We have the seeds here. I will change it, for example, 1 to 3 and 4, 5, 8 to have it more interesting. In recuperation we put just 3 and number of results 3. Now I start the secondary settings, where the input and output boxes are printed to our gene interface. So it will take a short time. Maybe it's a little bit longer than I expected. Yeah, now it's finished. In advance, I prepared the preview numbers from the previous draws, so I will try to copy them into the input box we got here, and I need to copy it again. So I hope, yes. So we have these numbers from the previous 3 draws, and we will start normally the generation. And you can see it's running. We are getting some best results, and I can end the generation. And when I ended the process according to the algorithm we have here, then the last seed and last swab were stored in these cells. And if I continue, or I can save it, but if I want to continue, I have to enable the transfer function. And now you see that the last seeds and swabs were moved up as the initial ones, so we are starting actually from the last save point. So I will continue again, and I will end it. And you see we got a new last seeds, but we have still the same swabs. It means that the chain of random numbers remains unique, so we don't need to swap the chain of seeds by the swap number, and only when this will change, when you end it, it's just a sign that the sequence was swapped to keep the chain still unique. So that's the explanation we have here. So we can continue still, and you can see that it's running. And we have again here a new last seeds, which will be used for the next upcoming generation we will start. Also, we can see the seed 1 and 2 as a stored values, and it actually determines that this number and this number were created based on these 2 seeds. What I can also do is, if I continue to transfer the numbers, I can change the last seeds to another numbers like this and this, and now you see that the numbers were used as the initial ones. So this is one way how you can also change the seeds by yourself and to change the sequence of generated random numbers. So I will end it at this moment and show you one final thing which I have in the presentation. And this is situation you can have a output box only with the future lot but no predictions, and it might happen that this output box will have very strong wave, so you want to use this wave for longer time, but you have only very short prediction, only one upcoming prediction for only one upcoming drawing day, and you want to have more predictions for more upcoming drawing days. In this case, what you can do is to take these stored seeds, put them into the seed 1 and 2, and create a new interface with also 2 predictions, and to start the gene again. Immediately you will get a first result, which will be the same like the result number 9 here, and you will get it already with the future predictions, but also with the other predictions like P1 and P2. And this I will show exactly here. So we can keep a little bit running the gene for a while, and we have the best result is number 3 with 22.3% of matches. So we can say this is the best result we got until now. So I will end the process and will copy the best result into the Notes tab, and then I will create a new interface. It means I will uncheck the transfer, click the activation, all the interface was cleared, and here the count of future rows I will put 2. You can have here a bigger number if you want to have the wave longer. Other thing, that's all I needed to do. I make the setting. So new input and output boxes are created right now, so it will take a little while again. And you see that we have here the future lot and also the 2 predictions available. I hope it will be finished soon. Usually during the live stream it's a little bit longer than usual. To be more correct and accurate, I will delete the last seeds and swaps. And now what I have to do is again to copy the numbers into the input box. And to get the same strong wave we have here, I need to take these 2 seeds and insert them here, like I have shown in the presentation. So these 2 seeds were used, and now I will start the gene. I have started that. But let me check it. Something is not really correct at this moment. So I took these seeds and swaps from the best result, and I would like to use them again. So now they are used and I should get the same result. Yeah, now I got it. I don't know really why I didn't get it before, but I got it right now and we can check it. That is the same best result. Maybe I should wait a little more longer time. And you see we have generated the same numbers in the output box. It's also the output number 3, but we have a different number of cycles. Here it is 406 cycles and here it's 542 cycles. But what is very important is we got the same generated numbers. We have the same numbers for future predictions, like you can see 29 and it's number 3 is 29 number 3. And then we have also, as the wave is here the same, we have also generated the predictions. And this procedure use only in case you will get really very strong wave and you like to make from this wave a longer prediction. In case you forget to make the predictions, you can have some prediction already, but you want to have the predictions longer, for example not only 2 but 5 and so on. So in this case you have a chance and the way how to make it longer, the prediction, with the same strong wave we have here. As we have, it was just a short time where we have only 0, 1 and 3 matches like here, but I mean mainly for the strong wave when the gene is running for a much longer time than I am presenting today. So that's all for today. Thank you for watching. Please subscribe to the YouTube channel and click the bell to be notified about new upcoming video tutorials. Do not forget to provide your feedback, comments, and I'll be glad for every like I will get from you. Join us on the Facebook page, groups, follow the links in the description. Stay tuned and see you next time on the actually 13th video tutorial where I will talk about recuperation. So thank you for watching and have a nice day.